What is slope? I'm a real fan of Tour de France, and let's see, yeah. And when they do the race, it does take place in France. They talk about the percentage or the grade of the mountain. There are 24 race. There's 21 races. They're called stage, and yes, there's 21 days of racing, and each one is about 200 kilometers, about 130 miles each. The steepness or the slope of the mountain is determined by the vertical climb. I looked this up, and yes, divided by the horizontal run. In Tour de France, that gives you a fraction. They convert it to a percent. So looking at this one, I know this one this racer is going up, so we call that a positive. And when we talk about the steepness, is I take any points, and we said it was the vertical climb or the vertical climb or the rise. So we go over the rise over to another point over the run. So in this case, he went 1, 2, 3, and to the right 3. So it was a positive 3 and a positive 3. And the slope is determined, we write that as a fraction. So this would be up. He went up 3 over 3, and that simplifies to 1. So let's say I decided to pick this point and this point. Well, it's 1 over 1. So that's still, regardless of what points I choose, it will still simplify to the same value. So look at this one here. So he is going from left to right. He's going down. We call this a negative slope. So this is what we call negative. And again, I'm going to pick any 2 points. And I'm going to pick this one. And I'm going to go, this time he goes down 1, 2, 3, 4. So down 4. And 1, 2, 3, 4, 5, 6. And to the right, 6, which is positive. So I would have negative 4 over 6. And I simplify that, and I get negative 2/3. So that would be the slope to this line, or in this case, mountain. And if I wanted to compare the two, I would change this to a decimal, my fraction, and compare it to this one here. And the first one was steeper because 1 is larger than 2/3. So that's how I would calculate the slope in the Tour de France. They tell you they compare the two mountains by how steep it is. So we're going to look at the steepness of a slope, or the steepness, or we're just calling it the slope. So its slope is always written as a fraction, and we see it as the rise over run. So I could go either up or down, just like I showed you in that little mountain figure, and my run is left or right. And to indicate up, I'm going to do positive. To indicate down, I indicate negative. So let's look at this one. So here I've graphed my equation, I've labeled it, and I have my points. So I want to find the slope to this. So I'm going to pick any 2 points that are on this grid. We call this a lattice point. I can't pick this one because it's not on my line. So I'm going to focus, what are the points that are on the line? So I'm going to select this one and this one. So I'm going to go up 1, 2, 3, 4. So I go up 4 and to the right 2. So that would be a positive. Because I know I'm going up where it slants to the right, I know this is a positive slope. So when I work my fraction, I should have a positive answer. So in this case, my slope, we use a letter M, and I think it's like French for like mountainous or something. But we use the letter M for slope. And it goes up. We said it went up 4 and to the right 2. And I'm going to simplify that to 2. So I always want to simplify my fraction. So I want to simplify. And then I want to make sure that, okay, what if I just picked this point and this point? So I went up 2 to the right 1. Yeah, I'm going to write it here. My slope is up 2 to the right 1, And again, that simplifies to a 2. And it's positive. We know it was positive because it went uphill, if you want to think of it that way. Now let's look at this one. We already know it's going downhill, so I know it's a negative slope, so I'm going to write negative, because I always want to look at it from left to right. So when I'm going from left to right, I'm going downhill. And I'm going to select 2 points, and I'm going to select these 2. And I'm going to count 1, 2. I went down, so I'm going to write negative 2. And I went 1, 2. Oh, sorry, it has to be on those little marks. So I'm counting that how many across. And 1, 2, 3. And I'm going the positive direction, so it's a 3. So my slope here is down 2 and to the right 3. If I continue that pattern, I will find more points. Down 2 to the right 3. What if, and you don't have to take these notes, but I just want to make a point. What if I went from here to this point? What if I went up, Miss McCarthy, and then I went to the left? So I went 1, 2, 3, 4 up, so that's a positive. And 1, 2, 3, 4, 5, 6. That's a negative 6. So I know my slope to that would be 4 over negative 6, which simplifies to 2, negative 3, or negative 2/3. So that's the same value. Actually, would you please write this in your notes? Again, my final answer is negative, so it concurs. Notice, regardless of the points, and as long as I do my rise first, that's my top number, it's rise over run, it does not matter what points you begin and end. Okay, let's look at this one. So here we've graphed horizontal, so I know here's my horizontal graph, and I want to talk about what's the slope of these kinds of graphs. Well, if I go back to the analogy of the Tour de France, so here's my bike dude. Is it steep? There's no steepness at all. So here my slope, but there's no steepness. It's nice and flat. My slope is 0. Super easy to ride my bike on that. But if I want to think of it as my rise over run, let's say I'm going to pick 2 lattice points. How much do I rise? Nothing. And I run 2. So it'd be 0 over 2. And calculator person, when I take 0 divided by 2, it is 0. Now let's look at this one. On my vertical, again, if I take my analogy, let's put their equation. Here I have y equals, because it crosses my y-axis. It's a nice horizontal line. All my y's are 5. So all my y's are 5. This one, see, these are all, my values are 5. So I know for my horizontal, there is no slope. It's a slope of 0. Okay, so m equals 0. Let's look at this one. Well, let's look at the equation first. So I know it only crosses the x-axis, so hence an x here. And where does it cross the x-axis? At 1, 2, 3, 4. Yeah, at 4. So, sorry, this is my line here. My bad. Here's my line. There's my line. It crosses my x-axis at negative 4. So all my x's are 4. If I were to construct a t-table, I would see that they're all 4. That's my equation. So what is the slope to this? So my slope to this is, well, if I pick 2 points and I do rise over run, I'm going to rise 1, 2, 3. So I rise positive 3 and I run nothing, 0. I can never divide by a 0. So this is a undefined, impossible. So take that. So undefined, not no slope, because that means it's not steep at all. We have to use the word undefined. Think of it as an analogy of my bike. Okay, it's impossible for me to ride my bike on this straight up and down mountain. Okay, so that's how I remember that. And let's look at this one here. So we will have to find the slope from a table. Now the slope, when I'm given a table, it's the change of this here is the notation that you'll see in your math textbooks often. This is a delta, and we read it as the change of y over the change of x. Specifically, here's a formula that we give you. If I subtract my y's and I subtract my x's, and those become my denominators, x's. This notation, when I have y sub 2 minus y sub 1, that means I take the point, my y, the point from my point. Sorry, I got a phone call, it distracted me. I take my number from my y value from my second point minus my y value from my first point. This notation means I take my x value from my second point, subtract that from my x value from my first point. That gets really wordy. I like to think of it, I'm just going to stack them and subtract them. So if I take any 2 points, I'm going to take these two because they're both positive. So here are my y values. These are my y's. And I'm going to take that difference. 2 minus 0 is 2. And this is the change of y. Over here, from 0 minus 3, it changed to negative 3. And this is my change of x's. So my slope would be 2 over negative 3, which we would write it as 3 over 2, negative 3 over 2. Next one. So here I'm going to take, it says to take the change of y, or just subtract them, subtract my y's and subtract my x's. Basically, that's what you're doing. So I'm going to pick these here, and I'm going to pick these. So I have to pick the same group of points. So in my change of y, 4 minus 8, so I'm going to write arrows to remind you which number went first, because order does matter. 4 minus 8 is negative 8, and 0, so that's my change of y. My change of x is 0 minus 2 is negative 2, so my change of y over the change of x is negative 8 over negative 2, which simplifies a negative divided by negative is a positive, and 8 divided by 2 is 4. So my slope is positive, and it is 4. Let's look at this one. So I'm going to take the first two. I'm going to write my arrows, so which ones I'm going to subtract in order. So here's my change of y. So negative 3 minus 1 gives me a negative 4. And here I'm going to do 2 minus 2, which is 0. My slope is the change of y over the change of x. That's what slope means. And my change of y is negative 4 over the change of x, which is this one, which we got 0. And previously we know we can never divide by 0, which that is undefined. If I were to graph these points, it would be a vertical line. So anytime I'm dividing by 0, that's undefined. And a mental picture it looks something like this. Okay. Here, when my 0 is on top, I could take 0 and divide it by 5 people, and they all get nothing. So my slope is 0. And that, if I were to graph it, would be a nice flat line. Okay, those are my horizontal. So let's look at this one. So I'm going to take the change of y. So I'm going to subtract here to there. Negative 3 minus a negative 3. Well, a minus is a positive, so I get negative 3 plus 3, and that gives me a 0. The change of x, I'm going to take the same points. So I have to make sure you're subtracting the same corresponding x value. So I'm going to put a little arrow. So I have a -4 minus a -5. So I always put that little parentheses in there. This is a minus, minus is a plus, and I get 1. So the change of y over the change of x, we said that's 0. That always goes on top because that's my rise. And we said that's 0. And my change in x is 1. That's this value here. Because we said, and now we have 0 divided by none. This is, so my slope is 0. So it's a nice flat line. There'll be times when I have 2 points, just 2 points. So I'm going to look at this one. So I could use this formula, but a lot of kids confuse the order. So I simply stack my points and subtract. So I want you to write stack and subtract, and I'll use that often. So I'm going to take these points and I'm just going to stack and subtract them. And it doesn't matter which order, which one is first. Okay, so these are my points. So basically I'm just putting them in a t-table. Okay, here are my x's and those are my y's. And I'm going to draw my arrows to let you know which ones I'm doing first. So my change of y, so here's my change of y, is 4 minus a -1. And that gives me 5. And here I'm going to do 3 minus a -3. Make sure you include that minus, and that gives me a 6. So here's my change of x. So the slope to this, I'm going to write it here, my slope of this is again the change of y, so it's top, because that's my rise, over my run is 6. And I can't simplify that. I want to leave things as improper. So if you ever get an improper, leave it as improper. Here's my next one. Again, I have 2 points, so I'm just going to stack and subtract. So I'm 1, -2, and 7, -2. Again, doing my little t-table. Here's my x's and there's my y's. And I'm going to show the directions of which ones I'm subtracting the order. So I know I'm going to subtract them. I have -2 minus a -2, and that simplifies to 0. This one I'm going to subtract them. 1 minus 7 gives me -6. And my slope, again, it's the change of y. So this one has to be on top. So 0 over -6, and that equals 0. I can have a 0 on my numerator. I cannot divide by 0. So this one's nice and flat. So now let's look at this one. Is that all I have? Oh, yay. Okay, so now let's look at this one. I have a slope of -3 over 2. So when I see this, my negative could be on top and my positive is on the bottom, or I could write it as 3 over -2. So it doesn't matter where my negative is, but the key thing, there's only one. When I have 1, make sure it's either on the top or on the bottom. It doesn't matter. So if I have it in this manner, that means I'm going to go down 3 because that's the negative direction, and to the right 2. Here, I would go up 3 and to the left 2. So now let's take this one here. I'm going to pick a point, some random point, and it has a slope of -1/2. So I could write it as -1 over 2 or 1 over -2. So let's do this one. I'm going to go down 1 to the right 2, down 1 to the right 2. Well, what if I use this one? Oh, no. That means I'm going to go up 1 and to the left 2. Well, it's up 1 to the left 2, up 1 to the left 2, up 1 to the left 2. Notice it's the same pattern that they're following. So this has a slope of -1/2. And then I'll connect it. Okay, so now let's look at this one. When I have a whole number, Let's go over here. I could write it as 2 over 1 or negative 2 and negative 1 because a negative divided by negative is a positive. So I know this one's going to go up 2 to the right 1 because that's the positive direction, or down 2 and to the left 2. So looking at this one, I'm going to start at the same point, and I could rewrite this as 3 over 1 or negative 3 over negative 1. So let's use this idea, and I'm going to make that in purple. It's going to go up 3, 1, 2, 3, and to the right 1. And I'm going to continue that pattern until I run out of paper. So I go up 3 and to the right 1. Now let's look at the other one, and I'm going to use blue. Let's look at this one. That means I'm going to go down 3 and to the left 1. So down 3 until I run out of paper. But it's the same pattern, 1, 2, 3 over 1, 1, 2, 3 to the left 1. So as long as the two have a negative, and that is a positive slope. So my slope is 3. Now just recap just the names of them when I'm looking from left to right. When I have a positive slope, it means that direction. When I have a negative slope, it means this direction. And notice they go through the X and the Y, X and the Y. A no slope is nice and flat. And the undefined, that's my impossible mountain. There's no way I could climb that mountain on my bike.